Before getting into more advanced concepts, let's look at the basics of AI. We need to understand some basic things like, let's just start by defining it, artificial intelligence, development of different computer systems capable of performing tasks that try to mimic the way that us humans actually think, process information, and can relate to the different environments in which we are. In other words, it's a thinking machine. And honestly, the definition is not more complicated than this. We're trying to understand things in a way, and a computer is going to replicate the way that we understand things ourselves. Understanding things like machine learning. When you have machine learning, this is where you have different steps at which an AI system is going to slowly gain an understanding of something so that it can finally give an output. In simpler terms, it has different parameters. These are mathematical probabilities where it's going to look at something and slowly understand what that thing is. To give an example, it is fed 10,000 images of different animals, and it is told that some of these animals are cats. It's going to look at the characteristics of these cats, but of course, in kind of a probabilistic way. It's going to see that, okay, pictures of cats have these little fuzzy edges. We know that as fur. Pictures of cats have round eyes and these little whiskers. It doesn't know what whiskers are, but it understands that there's a certain relationship between the data, which shows that these little white things on a kind of furry background are whiskers. It's going to understand that cats are shaped in certain ways with pointy ears, for instance. That is more something that relates to a cat than, say, a snake. Snakes don't have pointy ears, and so when it's deciding between both, it's going to say, I give a 90% chance that this is a cat, a 10% chance that this is a snake. Of course, it has a lot more animals than that, a lot more parameters, but it's slowly going to say it is more likely to be a cat, it's more likely to be a snake, it's more likely to be any other animal that it has been trained on. And through machine learning, it can slowly understand better and better what something is. It's going to be the same thing with, say, music. It gets the input of music, and it's slowly going to say, okay, I've determined that classic music has this kind of sound, this kind of pitches, this kind of data coming in. But say rock music, the data looks different. Maybe the pitches are different. The music, it isn't working in the same way. You have more percussion. It is going to say that something is closer to, say, rock music or closer to classic music, depending on the data that it has. Neural networks is the way that what we just said is processed. You have several layers of neurons, and in each of these, it's going to get closer to a final result. Okay, it has a database of thousands of pictures, hundreds of thousands of pictures of, let's say, everything. Okay, let's just download it from the internet. And we're trying to see which ones might actually be a cat. First, we feed it an image of a cat, and we ask it, is this a cat? So it's going to look at all of the images that it has had before. Some of these, it might directly have been told that this was a cat, and so it's going to look at the characteristics of this. First, it might eliminate anything that doesn't even look like an animal, okay? It's a picture of the sky, let's eliminate that. It's a picture of a computer, let's eliminate that. Because those things just don't seem to have the same characteristics, colors, texture, fuzziness, all of those things that we'd associate ourselves with a cat. It's going to get a little bit more precise, and then it's going to be deciding between, say, a dog and a cat. But see, cats have several different characteristics. And so we're going through the different steps of these neural networks to get to something that's a very large and undefined image. Sky is very different from a cat, but a dog has certain common characteristics. To finally refine it till we have something that produces an output, and the output is simply going to be a probability saying, okay, this is 95% sure this is a cat, right? Knowledge are all the kind of structured information that a system has to make decisions about the different things that it has. When I said that our model had tens of thousands of images taken from the internet, some of which are cats, then that is the knowledge that it actually has to be able to enable its reasoning, its automated reasoning. So some questions about this. What does AI refer to? We have 4 different answers: a process for optimizing a model's parameters, a neural network connected by adjustable weighted links, the theory of development of computer systems capable of performing tasks that typically require human intelligence, or a system designed to store and organize data. Pause now if you'd like a little bit more time. AI refers to a system capable of performing tasks that require human intelligence. Basically, AI will try to mimic in different ways, such as by trying to reproduce what we think we believe about the human brain, that we use neurons to finally get an understanding of the world around us. And AI is going to try to mimic that process. Let's look at some acronyms. For this course, we need to understand, first of all, what ISO is. It's the International Organization for Standardization, but I understand ISO doesn't actually go by International Organization for Standardization anymore. It just goes by the acronym ISO. But basically, they're the ones who create different standards. There's over 40,000 standards. I've lost count now that it's been increasing so much, over everything from, say, the water tightness of watches to how to treat uranium in a nuclear plant, to the ones that we know that are management systems. Some of the common ones include ISO 27001, which is management systems over information security, 9001 quality, 22301 business continuity. We have plenty more standards. In this course, we're going to be looking at the standard called ISO 42001, which is Artificial Intelligence Management Systems. In AIMS, so that's an Artificial Intelligence Management System, this is the ISO standard that we're going to be looking at in very deeply in this course. And in AI RMF, that's so an AI risk management framework. We have this model from ISO. There are others, for instance, from NIST. So our U.S. Department of Commerce has come up with a framework for the risk management of AI systems, which simply calls the risk management framework from, this is NIST. More acronyms. We have AGI, Artificial General Intelligence. This is an AI system with something that would be close to human-like cognitive abilities across various domains. And of course, there's a lively debate about whether we've already crossed this point, whether AI already has reached this kind of level at which it could be considered AGI, though many believe it is still far in the future. We have artificial superintelligence, and it's a hypothetical AI surpassing human intelligence in all fields. Now, this supposedly, when AI is as good as humans in all fields, then the next day it would be far superior to humans in every field as well. Artificial superintelligence is the idea, a point which we're still hoping is relatively far in the future, where AI would be able to surpass humans in every single way. And machine learning, we looked at the definition of it. It's often abbreviated to ML. It focuses on the algorithms that learn from data. We have NLP, or natural language processing. This is basically how AI deals with human language. You use Claude, you use Gemini, Copilot, you use ChatGPT. All of those systems try to speak with us humans in the languages that we understand best, and that is basically called natural language processing. Computer vision is where you have an AI system focused on interpreting and analyzing visual data, images, video. And reinforcement learning is where we have learning through rewards and penalties in a dynamic environment. We're going to be looking about the different ways that an AI system can learn about the environments in which it operates.